And this normal reaction depends on the weight of the body. More the weight of the body, more will be the normal reaction. So this is the general expression for your frictional force. Then if that is the case, what happens to your final equation? F by N, what should I do for F by N?
Mu.
Mu. What is F upon N? It will be mu.
Mu.
Ma'am?
Yes.
Ma'am, I divided the expression for the final expression.
Wait.
Like I took the denominator to the numerator.
No need.
Evaluated.
No. You can just only substitute F by N is equal to mu. If you substitute this equation becomes tan theta plus mu divided by 1 minus mu tan theta. Correct?
Yes, ma'am.
Yes, ma'am.
That must be equal to what? V squared by
Rg.
Rg. See, V is the speed. Keep this in mind, boys. V is the speed with which a car can move in a circular bank surface, so that it will not undergo skidding. There will be no skidding of the car. This will be the maximum permissible speed. V is the maximum velocity with which the car can travel without skidding. So now I want you to find what is the value of V, also an expression for V. Will you be able to find?
Is it mu Rg?
Is it mu Rg? Only mu Rg? You have an expression over here?
Ma'am, V is equal to root of mu Rg.
Okay. It will be Rg into this entire thing, mu plus tan theta divided by, no, in this expression was. Now look at this expression. Shall I erase all? I think so. I'm not able to erase this.
Yes, ma'am.
Was here, what is V squared? If I put a different ink, I think so. V squared will be equal to Rg into mu plus tan theta divided by 1 minus mu tan theta. This is what I am getting. Is that correct, boys?
Yes.
Okay. Now you find V. V will be square root. So write this. So what happens to V? V becomes equal to root of R into G into mu plus that is.
Ma'am, I have a doubt. I should have asked this before itself. Like,
okay.
Why are we dividing by n cos theta?
Why are you dividing by n cos theta? In that sense, you are simplifying it so that you are getting in terms of tan theta. That's it, nothing else. Mathematical.
And then you're supposed to divide in
by sin theta
also, right?
Which one? No, I can divide this by sin theta also. If I divide this by sin theta, in some cases I'll get cot theta.
Right? Okay, ma'am.
So if I get cot theta, finding the value of theta will be tough for you. You understand, because in your log table you can find sin theta, sin 50, sin 60. You can find the value of cos theta. You can find the value of tan theta. Is that clear, boys?
Yes, ma'am.
Yeah. If I divide the numerator and denominator, say by sin theta, then one of your term would have been, the numerator would have been cot theta. If you want to find cot theta, Clark's table doesn't directly give cot theta. So tan theta would be comfortable. Otherwise, what you have to do is that look at the expression. Sometimes you need to find the value of sin theta. In some case, you need to find the value of cos theta. If I don't divide this by cos theta, look at the numerator, n sin theta plus mu cos theta. So you will have so much of complication. You have to find sin theta, you have to find cos theta. But now you are getting only tan theta. easier for you to find. If the value of theta is given, you can easily find the value of V. That is the reason you're dividing it by n cos theta.
And what about RHS?
What about?
RHS?
RHS now becomes square root of R into G mu plus tan theta
Don't
by
you have
1
to divide by cos theta? Like,
No need, right? No need.
Ma'am, because we did it on LHS, right? So we
Okay,
have to do it on
okay.
RHS.
Okay, one second. If you have that doubt, have you completed this? I'll clarify that doubt. What you people have done, what you people have asked. Why not? This should have been done with your right RHS. Have you completed this?
Yes, ma'am.
Okay.
Ma'am,
Yes. What happened?
we're supposed to find an expression to find the angle of banking, right?
Yeah. That's okay. That I will do. That comes as a special case. Have you completed this P?
Ma'am, I have a doubt.
Okay. Yeah. Yes.
Ma'am, before we had an equation saying that V max equals root of mu RG.
That was in a level road, boys. That was in a level road. This is a
different condition.
bank. Yeah, this is a banked road, right?
Correct. Thank you.
And someone was asking a doubt. You are dividing numerator and denominator of LHS by cos theta. Why not the right side? Right hand side. You completed the value of V. Shall I do a new slide and show you?
Ma'am, your voice is breaking.
Okay. Is that fine now?
Yes,
Is
ma'am.
it okay? So have you completed this? Finding the value of V?
Yes, ma'am.
Okay. Now, let me go for that. I'll take some other expression. So you people have asked me. So I have A plus B divided by C plus D, E by F, right? So let me multiply. That's what we into 5 divided by 5, correct? That's what we were doing. So sorry. This is equal to E by F. So we were dividing numerator by 5, denominator also by 5. That's what we have done, right? You're dividing numerator by 5, denominator also by 5. So if
Yes,
I
ma'am.
okay, wait, if I go
Yes,
for
ma'am.
this, wait, if I go for this, this comes to be, see, dividing numerator by 5, denominator also by 5. This is how your expression comes to be, right? A plus B by 5. It means that A by 5 plus B by 5 or A plus B by 5. Is that correct, boys? What I'm doing is correct?
Yes, ma'am.
Okay. Now, if I do this, will not these 5 and 5 denominator and denominator will get cancelled? A plus B by C plus D. This was your previous expression. A plus B divided by C plus D was E by F, right? So when I divide the numerator by 5 and simultaneously I'm dividing denominator by 5, same amount, then what is that I'm getting? I'm still getting the same expression. So dividing numerator by the same quantity and denominator by the same quantity, this is not going to affect the equation at all. Do
Okay,
you
ma'am,
understand?
got it.
It's not going to affect the equation at all. It is only for your simplification you are doing. You're simplifying it, but at the same time, the expression should not be get affected. I think you're not convincing.
Yes, ma'am. Got it. Understood.
What
Yes,
is
ma'am, understood.
your mathematics?
Ma'am, so it won't make a difference if you do it
It will
to
not,
the
yeah,
RHS also.
always, boys, keep this in mind. Not only in this expression, in any mathematical expression, if you divide numerator by any number and you divide the denominator also by the same number, the entire expression will not get affected at all. Same thing happens if you multiply your numerator by a number, then denominator also by the same number, still it will not get affected. See, I'll go for this. A by B, I'll multiply by 5 and 5. 5A by 5B, what does it give? It gives the same number, same expression. Whether you multiply your numerator and denominator by the same number or divide numerator and denominator by the same number, your expression will never change. It will be still A by B. Is that clear?
Yes, ma'am. Got it.
Okay, this is what you have got. This is the safe velocity with which a person can travel along a circular bank surface. Now let us see a special case when there is no friction between the tires and the road. Suppose if this happens in high condition, when there is no friction between the tires and the road, which means it's completely frictionless, mu becomes equal to 0, right? If mu is 0, it indicates there is no friction. Then I want you to get an expression for V. What happens to V?
Basically, root of Rg tan theta.
Okay, V is equal to 5. So when there is no friction, then V is equal to root of Rg tan theta. This is what you're getting, right? Right, boys. Special case is important. Then, see, when there is no friction, what happens to the wear and tear of the tire? See, there cannot be a condition where mu is 0. See, always there will be some amount of friction, but we are just considering the friction is negligible, which means mu is approximately equal to 0,
So
and the velocity is.
there will be no wear and tear, right?
Yeah. So then there will be no wear and tear. If friction is not there, then the wear and tear of the tires will not be there. So in that case, what is the angle of inclination? Tan theta. What will be tan theta? Can you find tan theta from this equation? So what is V? What is V? V is the speed with which a car can move along a banked circular track when there is no maximum speed, when there is no friction at all. If that is the case, right, then what should be the angle of banking? Angle of banking is the angle between angle with which the bank surface makes with the horizontal. So what will be tan theta? Can you get tan theta from this equation? How will you get tan theta from the equation?
E square by Rg.
V squared is equal to, I'm squaring this expression, boys. I'm squaring this expression. Let me square the above expression. V squared is equal to Rg tan theta. Okay, then what is tan theta? What will be tan theta? V squared by Rg. Or what is theta? Theta will be tan inverse of V squared by Rg. So this will be your V squared by R into G.
Ma'am, can you repeat why did you square V?
No, I want to get an expression for tan theta, right? I want to get an expression for tan theta so that I'll square both the sides. So when I'm squaring both the sides, left hand side becomes V square, right hand side becomes Rg tan theta.
Yes, ma'am.
Okay, then you can easily get an expression for tan theta.
Ma'am, but mu is equal to 0 is a utopian case, right? Because
Yeah.
is it possible for friction to be 0?
No, boys, you cannot have an hypothetical condition. Or you can approximately, if I take it approximately 0, it cannot be 0. I can take it approximately 0, then I can go for the velocity. If that is the case, then what should be the angle of inclination?
Ma'am, when we write the derivation, should we write the special cases as well?
Yes, you have to write. Statements are important.
So ma'am, this is the final formula, right? For the angle of
That's it.
bang theta is equal to
Correct.
tan-
Correct. Boss, correct. So
Okay.
you have three expression. You have to by heart. Because when you're solving your numerical, you cannot derive, right, boys? You cannot derive these equations. All the final expression you should by heart. We'll do a numerical, then you'll understand.
Ma'am,
Yes.
ma'am, is this the end of the chapter?
No, one small topic is there, bending of cyclist, and then a graph is there. I think most probably I'll be starting by tomorrow the new chapter, work, energy, and power.
Okay, ma'am.
It's a lot to yes.
Just- I just want to confirm in this, V is the maximum velocity, yeah?
Correct.
Ma'am,
Yes.
which one is maximum velocity? Okay, ma'am.
This is the other one is safe velocity, right? Safely you can travel with this velocity.
Okay, ma'am.
Kritya is present or absent? Kritya? This microphone is not working, boys.
Present.
Surya?
Yes, ma'am.
Shushal? Shushal, your microphone is still not working. Shushal? Fine, boys. We'll start with a numerical. After this numerical, I'll give you 5 minutes break, then you come back.
Thank you, ma'am.
Shall I move for the next slide? Boys, shall I move for the next slide?
Sure, ma'am.
Write this question, boys. A circular track of radius r is equal to 300 meter is banked at an angle of 15 degrees. So theta is 15. The coefficient of friction between the wheels of the car and the road is 0.2. Now the question is optimum speed, right? Optimum speed in that sense, the speed with which the car can travel without slipping to avoid wear and tear. Sorry. This becomes maximum speed when there is no friction at all. Can you see this? Avoid wear and tear of its tire. So avoid wear and tear of its tires means friction is very less. When you go for slipping, it is this. Without skidding, this is the maximum velocity. When it is to avoid wear and tear, so friction is almost zero. So mu becomes equal to 0. You have to use this formula. V is equal to V naught is equal to root of Rg tan theta. So you have to check. You have to check this words. Avoid wear and tear of its tires, which means your friction is kept as low as possible, which you have to take mu as 0. So use this equation. Now the next one, without slipping, then you have to go for V maximum with your value of mu. You can take it as. Will you be able to find this? Okay. You know how to find tan 15, boys? Do you know how to find tan 15? Do you have your lab manual with you right now? Anyone who is having a lab manual? Do you have a lab manual? 11B?
Yes, ma'am. I have.
Okay. Take your lab manual, go for natural tangent. Those who are having your lab manual, please bring your lab. Yes, boys.
Ma'am, is it necessary to find the
You have.
tangent?
Otherwise, yes, boys. Otherwise, you can't solve. You have to go for it. Okay. Fine. You have lab manual, or else you have the log table. Do you have Clark's table with you? Logbook is there.
0.26.
Ma'am, will the log table be
79.
given in the exam?
Go for your log table. Go for natural tangent. Natural tangent. You have to be very careful, boys. You will be having. So theta might be 15 degrees. Things. The first one is 0 minute. So we'll be having 14, so something like that. Because it's only 15 degrees.
Ma'am, the value will be given in the exam, right?
No, you will be supplied with log tables.
Okay.
You have to find it. So that's what I'm
We have
asking
to
you.
find the value.
Yes. Do you have log table with you, boys? Since calculators are not allowed for CBSE examination, you should know how to use your log tables. Okay. Should I take a copy and show you, boys? See, look at the value. You have to go for natural tangent. You have to be careful. There is what we call it as logarithmic tangent, not that page. You have to go for natural tangent. So 15 degrees. Then next you will have an adjacent column where you can find the value. What is the value of tan 15?
0.2679.
So tan 15 is 0.2679. So that becomes 28.1 meter per second. Boys, I'll give you 5 minutes break. The second one, you can do it as a homework. Boys, only substitution. You know what is the value of tan 15? 0.2679. So you know the value of R, acceleration due to gravity. You want to take it as 10, take it as 10. Mu is given as 0.2. So you can use the second one. It's direct substitution. First one you copy down. Second one you do it as a homework. So now it is 12:45. 12:50 you come back. Because same subject you will find it difficult. Just
Ma'am?
yes.
G is 9.8, right?
Yeah, I have taken it as 9 point. I have taken it as 9.8.
Okay, ma'am.
Here I have taken it as 9.8.
Now we have to. We can leave the meeting and come back, or have to stay over here for 5
No,
minutes.
you stay. No, you stay. No, you just go. Come back at take 5 minutes break and come back.
Just confirming on that.
Yeah. And if you are comfortable, you carry on with the next numerical. If you want to have water, you have your water and come back.
Ma'am,
Yes.
is it like possible, like instead of giving us like 5 minutes break, now you could leave us kind of early?
Not possible, boys.
It's almost the
No,
same
no.
thing only.
Because it is a continuous period, so we thought it would be tough for you. Just have water and come back. No, I cannot do that, boys, because the timings are all from school. You know, the school has set the timings. I cannot go beyond that. Who was it? Is it Ken's? Who was it? Oh, no, boys, I cannot. No, I cannot do that, boys. If you want me to extend 10 more minutes after your class, fine. That I can do.
No, it's fine. It's fine. It's fine. Don't even.
If you want, I can
Ma'am,
extend the
it's,
time.
ma'am, it's okay. You can give us our break and you can leave the class at 1:20. We don't mind.
Who will finish my portions first? Your portion has to be completed,
Ma'am, you have 3 periods in one day, ma'am.
but not sufficient, right? Is it any? What is that we have done? Generally, when previous years we used to do at least. On an average, I'm speaking in a class. We used to do at least 3 derivations plus 5 numericals. Right? This was like what we used to have face-to-face learning. Now I don't know what is the pace. I'm not able to find the pace because I'm not able to understand whether you people have understood this concept. That's the challenge, right? We used to do at least 2 to 3 derivations rapidly and then complete at least one full worksheet comprising of 5 numericals. We used to do a lot of worksheets, right? So now look at the pace. If every day, if you can spend 10 more minutes, then it would be fine. But reducing is not at all allowed.
Ma'am, this 28.1 meter per second, is it
Yeah.
the highest velocity that it can
Correct,
go?
correct, yes, correct.
Ma'am, so if it goes higher than that, there'll be more wear and tear.
Higher
Ma'am,
than
it was
this,
break, right?
it is not a break. I have given.
Yeah, ma'am. Thank you, ma'am. But
And now you come back, boys. It was such a tough subject.
Ma'am, can you show the questions, ma'am?
1 second. I'll just put this. Okay. I think it's 5 minutes is over.
Ma'am, did you start the class or something?
Yeah. Now what we have done is, boys, first we started with a car moving along a leveled road and taking a U-turn or taking a turn. That is what we learned. A car is moving along a leveled road and it takes a U-turn. Second one, we have studied a car moving on a banked road, not a level road. It's the road which is sloping towards the center, where the car is taking a circular turn. So both the cases, the car is going to take a U-turn. One is on a level road, the other one was a banked road. In level road, see, when you move in a circular path, there should be always a force which is directed towards the center. Such force, we call them as centripetal force. See, when you take a U-turn, generally while you drive, you take a U-turn, right? When you're driving a car, you generally take a U-turn. So when you take a U-turn, you're moving in a circular path. So when you're moving in a circular path, there should be a force which is acting towards the center. We call that such forces as centripetal force. Now, what provides the centripetal forces? The frictional force between the tires and the road is going to provide the centripetal force. But when you're moving on a banked road, right? When you're moving along a banked road and when you take a circular turn, now what provides the centripetal force? It is not only the frictional force, it is the component of N, frictional force plus the component of the normal reaction. These both together constitute the centripetal force. Is this concept clear, boys? Is this concept clear? So in a banked circular road, when you take a U-turn, the centripetal force is not only provided by the frictional force, it is being provided by a component means a part of the normal reaction. So far it's fine. Now, have you seen a cyclist always leans inward when he takes a circular turn? So when a cyclist takes a circular turn, you could have always seen the cyclist always lean inwards. Now, why does the cyclist lean inwards? That is what is your next topic. Okay, boys, I'll go for it. Bending of cyclist. Right, boys, the heading, next derivation is bending of a cyclist. I think others have come back.
This even applies to bikes.
Yes, yes, boss.
This even applies to bikes. Yeah, race bikes.
Race bikes. Is the friction is less? Yeah, I think so. Might be when the friction.
See how much they bend, like. So
Correct, boys, correct. Because what happens is that if the friction is less, then something has to contribute to your centripetal force. So when he is going to bend, he creates a component of N which provides the centripetal force. We'll see that here. Bending of a cyclist. Now the question is, why does a cyclist lean inward when he's moving along a curved path? This is what you're going to study, right? Right, boys, subheading, bending of a cyclist. Write the question because an important 3-mark question. Okay. Diagram is this. You can go for this diagram, not the one where you have the pictorial one is not necessary. What is important is the block diagram, what is being marked. Don't go for this diagram. This is for your pictorial representation. You will not have time to do this. Okay, fine, boys. Write the question. Why does a cyclist lean inward when moving along a curved path? Right? Determine the angle through which a cyclist bends from the vertical while negotiating a curve, which means he's going to bend to an angle. Now you have to find what is the expression for this angle. Copy down the question, boys, because questions are very important. You should know how to answer a question. You might know the concept, but you might not know what way you need to answer. I think 11B, you're right there, right? I need not check every, should I call out your names? Samuel, Steve.
Yes, ma'am.
Yeah, there. Have you copied the question, boys?
Ma'am, minute.
Okay. Now comes this is your question. Now comes the answer. Surya, or else I'm not hearing Kritya. Kritya, are you here in the class? Kritya, are you here in the class? His microphone is not working, boys. Okay, Surya Narayanan. Okay, Surya Narayanan, read out when a cyclist goes.
Okay. When a cyclist goes around a curved path, centripetal force is required. The force of friction between the tires and the road is too small to provide necessary centripetal force.
Okay. Right, next. That is why?
That is why a cyclist going around a curve leans inwards, because then the horizontal component of the normal reaction provides the necessary centripetal force.
Okay, good. See, boys, the cyclist is moving along a circular path. So we have seen that any body which wants to move in a circular path, there should be a centripetal force acting. Now, generally, centripetal force is provided by the frictional force. See, when the cyclist is riding the cycle, the frictional force between the tires and the road is very negligible. See, the frictional force provides the centripetal force. If there is no centripetal force, no one can move along a circular path. Since the cyclist is riding a cycle, the frictional force between the tires and the road is very small. You can see the dimension of the tire. So now, what if frictional force is very less? Something has to provide the centripetal force. Now you have to check which is the force which is acting towards the center of the circular track, that is your centripetal force. Now let me draw that over here. Now look at this, the cyclist is bending along the circular track. His weight is acting vertically downward, correct? Right? mg is acting vertically downward. Now look at the normal reaction. This will be the normal reaction. Normal reaction will always be perpendicular to the cycle, and this normal reaction is making an angle theta with the vertical. So then this normal reaction n is divided into two components, n sine theta and n cos theta. Is that clear, boys? Should I redo this once again? I'll redo the.
Ma'am,
Yeah.
ma'am, why is the force of friction very small?
Look at the dimension of the tire. If you look at the dimension of your cars and heavy vehicle, and look at the dimension of the tire,
All right, ma'am.
that's the reason, right? So weight is acting vertically downwards. Boys, please listen. The cyclist is not upright. The cyclist is leaning towards the circular path. So normal reaction will be always perpendicular to the surface. So this becomes your normal reaction. This normal reaction is making an angle theta with the vertical. Right? So that this becomes n cos theta and the horizontal component becomes n sine theta. Are you clear? So n is split into two components, n cos theta acting vertically upward, n sine theta acting horizontally. And this n sine theta is acting towards the center of the circular track. Are you clear, boys? N sine theta is acting towards the center of the circular track. And this n sine theta is going to provide the necessary centripetal force. If there is no centripetal force, nobody can move along a circular path. So n sine theta provides the necessary centripetal force. Question is, you have to find the angle theta. Was write down all these 3 points. Sorry. All the 3 points and only this diagram. No need for the diagram with a person. You can only go with a block diagram. Diagram is very important, boys. So theta is the angle with which the cyclist is bending with respect to the vertical. So this I don't want, only this.
Ma'am,
Yes.
Ma'am, are these sentences part of the introductory statement for the derivation, or that comes later on?
No, that comes later on, boys. This is for the first part of the question. Whatever you
Alright.
have written is for the first part of the question. Next part of the question comes your introductory part.
Alright.
Have you completed? I can move for the next slide, boys.
1 second.
Okay.
Ma'am,
Yes.
ma'am, the angle has to be drawn twice
No,
in the
not
second diagram. No, ma'am.
no, not necessary, boys. No. Shall I move for the next slide, or you need time to complete this, boys? Do you need time to complete? Maheshwar? Maheshwar? Rishit? Rishit?
Ma'am,
Yes.
Maheshwar replied in the chat
Okay.
that he doesn't have a microphone.
Rishit, Derek, and Danish are new students, right? New admission. Rishit, Derek, and Danish. Rishit, I'm speaking to Rishit. Am I speaking to Rishit? Danish, are these topics already covered for you?
No, ma'am. They only did the first part, like the starting part. After that, they didn't do.
Okay, fine. Danish, is it difficult for you?
No,
Kind
ma'am,
of
it's fine.
It's fine.
Yes, ma'am.
Derek?
Yes, ma'am.
Derek is difficult. Derek,
No,
you need any help from us? Do you need any help?
no, ma'am. It's
Boys,
fine.
okay, boys, it's for the entire 11B, boys. If you are finding it tough, let us see where we can adjust our times and timings, and let us see we want to redo, because chapters we need to move forward. So if you have any difficulty, please, you have your group 11B, just put a statement over there, boys. Shall I move for the next slide? Shall I move for the next slide?
Yes, ma'am.
Fine, boys. Now, your horizontal component n sine theta provides the necessary centripetal force. Okay, fine. Just write this. This statement is enough right now. The horizontal component provides the necessary centripetal force. So n sine theta must be equal to the centripetal force mv squared by r.
Ma'am, do we have to write suppose?
Okay, fine. Because you should know what is theta. Suppose the cyclist bends inwards to an angle theta from the vertical. Look at this. This angle is theta. Theta is, this is vertical. Can you identify? So the cyclist is bending to an angle theta with respect to the vertical. Is that clear, boys? Are you clear with the statement? The cyclist is bending to an angle theta with
Yes,
respect
ma'am.
to the vertical. Okay. So the normal horizontal component, should be n sine theta, is going to provide you the centripetal force. So n sine theta must be equal to mv squared upon r. So then now you tell me which are the other two balancing forces. Jatin, Jopal, Which are the other two balancing forces? See, n sine theta is fine. Leave n sine theta. Can you find any two forces which are balancing each other in this diagram? Jopal and Jadra. N cos theta, fine. These two are balancing. Right, boys. So the vertical component n cos theta balances the weight mg of the cycle and the cyclist. Now, my aim is to find the angle theta. Okay. Can you divide equation 1 upon 2? Dividing 1 by 2, just get me an expression. What will be 1 divided by 2?
Tan theta is equal to V square by RG.
Tan theta will be equal to V squared divided by RG, or theta becomes equal to tan inverse of V squared by RG.
Is this the last subtopic?
Yeah. We have to do numericals, boys. Let me see. Last class I had to do some numerical based on frictional force. I told today last period I'll solve. Let me start. You complete this. So make it a point, at least one derivation or at least two derivations. Please do practice, boys. Right? Retaining these things in memory will be tough. So that's what I'm telling you. When you're practicing 3 times you look into the your work and practice. 4th time without seeing diagram, rough diagram. Later on you can transfer it to a fair copy.
Ma'am, is the derivation for conservation of momentum still there in our syllabus?
Yeah, I have sent you the syllabus, right?
All right, ma'am.
Okay, well, let me check what might be the topic for you for your half-yearly examination. We will give you the topic. Fine. Shall I move for the next one, boys?
Yes, ma'am.
Okay, then the angle through which the cyclist bend would be greater. That you can see from your expression itself is. So when the radius, when r is small, theta will be have you seen this? When the radius of the circular track is small, the cyclist has to bend to a larger extent. Is that so? You ride cycles, you people ride cycles. That's the same, correct? Okay. When speed is greater, when the speed of the cyclist is large, this theta is also when the cyclist goes with a greater speed, he has to lean to a larger angle. Is that what you experience?
If you don't, then there's a high chance of not making the turn properly.
Okay, fine. So technically speaking, all these terms are correct. Yes.
So,
Most of you ride. Most of you ride your cycle, right? So you have experienced
Do we
this.
write this?
Yes, ma'am.
No, you need not write, boys. You know from the expression itself, you can tell, right? Okay, I'll start with the numerical, whichever was left. I just want this to take time. Okay, I want this equation. What is the acceleration? Now, can you see this diagram? You have a trolley of mass 20 kilogram. Now, this trolley, say it is placed on a tabletop. The trolley is being pulled by a string which is moving over a pulley The other end of the string is attached to a weight, say a block of of mass 3 kilograms. First, you have this is a system of a trolley and a block. A trolley of mass 20 kilogram is placed on a wooden table. Now it is being pulled by means of a string. The string is passing over a pulley. The other end of the string is attached to a block. Clear? The block is having a mass of 3 kilograms. The moment you attach the block, now what will you notice? Because the moment you attach a block, what will you notice? Generally, what do you notice? 7B.
It starts moving.
Moving in which direction? Block moves in which direction, boys?
Block moves down.
Yeah, block is going to move down. What about the trolley?
Ma'am, the trolley will move like towards
Oh.
the pulley.
Correct. This is what the motion. Sorry. This is how the motion happens. Trolley will move forward. Block will move downward. Now the question is, what is the acceleration of the block? I have to find the acceleration of the block. See, this is a connected motion. In connected motion, when two bodies are being connected together, acceleration of both the bodies will be the same. Are you clear?
Yes, ma'am.
Acceleration of both the bodies are the same, and the tension, that is the force which is acting along the string, will also be the same. Clear? So you have to write the question, you have to draw the diagram, boys. A very important question from your textbook, which often repeats in your exam. Write the question, draw the diagram. I think only that much time you are having, but still do it, boys. And look at this. When the trolley is moving forward, there will be a frictional force acting, right? There is a force of friction which is acting towards left. The trolley is moving forward, so there will be a frictional force acting between the wheels of the trolley and the table top in the opposite direction. That is your kinetic friction. So draw the diagram, write the question. I don't know. What is the acceleration of the block and the trolley system shown in the figure? If the coefficient of kinetic friction between the trolley and the surface is 0.04, what is the tension in the string? Take GS 10 meter per second squared. Neglect the mass of the string. So you draw the diagram right now, then we have to deal with both the objects separately. Copy down, boys. Fadhan? Fadil? Yes, Fadil.
Yes, sir.
Copy down the diagram and just draw the diagram, boys. Yusuf?
Yes, ma'am.
Okay. Yusuf and Kritya, I'm not hearing in the second term. You both boys don't speak. But generally, I have heard you people in the term 1. Now, term 2, you are the boys. I'm not able to hear you.
No,
What
ma'am.
happened? Yes, what happened?
Ma'am, nothing, ma'am.
Okay,
It's
fine.
taking a little time for me to understand.
Yeah.
So,
It takes time for you to understand.
yeah. So,
Yeah.
but I understood the concepts.
Okay,
So
fine.
I don't have any doubts, but I have to keep on doing it again and again.
Fine.
And what's the value of G over there?
What's the value of
G.
10?
Is it
Because they have
6 to the power minus 7?
no, G is 10 meter per second square. But the diagram is being drawn. Have you drawn the diagram?
Yes, ma'am.
Yes.
Okay, fine. Now I'll go for the one second. Now we'll go for the first one for the block. For the block, let us draw the free body diagram. Free body diagram is nothing but all the forces which are acting on the block. So you have to draw all the forces which are acting on the block. So if I consider the block, the weight of the block is acting in the downward direction, then immediately there will be a force of tension that is acting along the string in the upward direction. Are you clear, boys? Two forces are acting on the block. One is its own weight pulling it downward, and there is a force acting along the string to which the block is attached. Now, in which direction the block is moving? The block is moving in the downward direction. So the block is experiencing a net force. Is that clear, boys? If I have two forces, say a force of 10 Newton is acting downwards, a force of 3 Newton is acting upward. Two forces are acting on the body. Now, what will be the total force? What will be the total force acting on the body? 11B. I have a downward force, 7 Newton. Okay, in which direction? Okay, tell me in which direction the body will move. Downwards. Yeah. So this is the basic concept. So now the body is moving. Indeed, is.
It is 30 minus t because the body moves downwards.
Correct.
Is
Net
that
force. Because correct. Because the net downward force is greater than the upward force.
Okay.
When the downward force is greater than the upward force, the body will move down. If the upward force is greater than the downward force, the body will move up. So here, which is your downward force? 30 Newton minus
30 Newton minus
that will be,
tension.
That gives you the net force. That gives you the net force acting on the body, boys. If this is 10.
So net force is 3a.
Okay, so net force will be equal to 10 minus 3. That is 7 Newton. Same way. 30 minus t is the net force. Now, how will I write force in accordance to your Newton's second law of motion? F is equal to mass into acceleration. This is how I write. This is the expression for the force according to Newton's second law of motion. What is that? The mass of the body is 3 kilogram. Is that the mass of the body 3 kilogram, boys? Mass of the block? M is 3 kilograms. Okay. So 3 into A, this is the force acting on the block. So 3 into A must be equal to 30 minus T. I think so. I'll stop till this. Just only for the block, boys, only for the block, you draw the block diagram and just complete till this. Trolley, I'll do it next class. So, net force is mass into acceleration. Copy till this was, then those who have copied can leave the class.
Ma'am, the acceleration of the block and the acceleration of the trolley both will be same.
Same because they are connected bodies.
Alright.
Ma'am, can you upload this?
Boys, yesterday I was trying, I upload, yesterday I was trying, I was not able to upload. I don't know whether the size of the file is increased.
Or you can send us in the WhatsApp group.
How to send this in the WhatsApp? No, let me once again try. Once again, boys. Have you copied?
Yes, ma'am.
Okay, then I will try to send right.
The block party.
Only the block you can do. Trolley, I'll do it tomorrow.
Ma'am, trolley is actually 20 kgs, right? Then it's supposed to be 200 Newton.
100, yes. There was an error. Just I have to change.
Okay, ma'am.
Fine. Okay, boys, you can leave.
Thank you, ma'am.
Thank you, ma'am.
Okay, boys.
Thank you, ma'am.
Thank you, boys.
Thank you.
Thank you, ma'am.
Thank you, ma'am.